How's it going, guys? It's Jiggy here, and in this video we're going to be taking a look at modeling big data. We'll look at an alternative to the relational model, which is called fact-based modeling, and then we're going to take a look at how big data can be represented using something called graph schemas. So first, let's take a look at fact-based modeling. This is where data is stored alongside timestamps. Unlike the relational model, the data is never updated, it just continues to grow. A really basic example could be someone getting a new phone number. In a relational database, you just swoop in and update the row with the updated number, like so. In comparison, the fact-based model means you'd have the old number alongside a reference to the time at which it was stored, and that's called the timestamp. And what you'd then do is add a new number to the dataset along its new timestamp, like so. The phone number is what you would call a fact in the model, which is just a single piece of information. And then you'd be able to tell which is the latest by comparing the timestamps. So, nothing is deleted in the fact-based model. It just grows and grows because updating a current fact has the effect of just adding a new one, except of course with a new timestamp. The fact-based model is really a simple way of storing data, and it can be updated pretty instantly, which is why it can be an effective way of storing big data sets. Now, there isn't a single standard representation for the relational model. You can really represent the fact-based model in any way you like, such as using a diagram or a written language. One of the ways to capture dataset structure using a fact-based approach is with graph schemas. As you should have covered earlier in the course when you looked at graph data structures, graphs have nodes and edges. In this context, a node represents some entity being modeled, and an edge refers to the relationship between those two nodes. In this example, we're going to have two instances of the teacher entity and one of the student entity. Each box is a node of the graph. Now, there isn't a single set way to draw a graph, so unfortunately you're going to have to adapt to whatever AQA throws at you in the exam. All graphs will have shared characteristics though, such as nodes and edges, and they may look aesthetically different. An example of differences in diagrams is that timestamps are often omitted for clarity, and the most recent dataset is shown instead, even though everything is still stored like we discussed before. The edges are the arrows, which are labelled with a type of relationship that links the nodes. You then have properties, which are bits of data that are relevant to a node, and in this graph, all the entities share the common property of their name. In our graph, they are shown within the nodes, and in a different graph, the timestamp might be recorded here too. For large datasets, well-designed graphs are more efficient than relational databases, simply because you can traverse them by following the edges in order to locate the data you need, rather than just searching through a bunch of tables. So that's it for the big data topic. Hopefully you've not found it too bad, and it is a fairly trickier topic, and it does overlap with functional programming. This should be super fresh in your mind, but as we looked at earlier, we will use fact-based modeling with big data instead of a relational model. We can then put these facts in a graph, whereby a node is some entity which is usually contained in a box, an edge represents a relationship between the nodes and is usually represented using an arrow. You then have properties within a node. A timestamp may also appear in a graph, but they can sometimes make it too confusing, so don't worry if they've been omitted. Thanks for watching.